Come on, give me something. Fucking hell, I'm so dumb. Fucking hell. Oh my god, I misclicked. Oh my god. I misclicked. Not doing good today. Oh my god, I'm so bad. I'm so bad. I'm so bad. How do I do this? Okay, that works. How do I do? Oh my goodness, I'm doing it. Yep, I turned off Google Assistant today. I remembered to do it before I started stream. Holy crap. Oh no, please. God damn it. Oh, God damn it. That's unfortunate. It was a pretty slow run too. Oh well. Oh, miscounted. It's kind of cold today. I don't know. My hands aren't very responsive. Keep misclicking everything. Today just is not a good day. Oh my god, I'm so dumb. I'm so dumb. Why did I click that? I'm so dumb. Hooray, I got that one. Damn it, I missed that one. Ugh. Oh, man. Why does it do this? Why does it do this? The F11? Yeah. Happy Saturday to you too. Carrier arrived. Just a few more minutes until we got started. Is the volume a bit low? Probably it's a bit low. Sitting. Okay. I can up my mic gain a little bit, I guess. I'll just speak up a little bit and sit a little bit closer to the mic. I don't really want to be messing with like noise stuff right now. I don't really know. I don't know much about it, so I'll just sit a little closer. Okay, well, it is 12 noon, so welcome everybody to the third session of the Intro to Fullstack Dev Workshop on HealthyGamer. So today we're going to be talking about what is an API, talk about how APIs are built, and specifically about distributed systems and system design. And we'll talk about databases specifically because databases are incredibly important inside system designs. So, what's an API? API stands for Application Programming Interface. Okay. What it is it defines what sort of inputs that you give into a black box and what sort of outputs that you expect to get. It's called a black box because it's opaque. You don't know what's inside it. You don't know what sort of magic they do, but really you don't really care. You put something in and the black box says, and the API contract tells you, you get something out. And that's what it is. So like, there are several kinds of APIs. Well, let's be clear here. Like your operating system is an API that interfaces with your hardware, for example. So if you've done any Windows programming, I doubt very many people here have, but if you do any Windows programming, Windows defines like a whole bunch of APIs to like open up a window or like talk to files or whatever, right? The operating system, Windows, defines these APIs, and you don't really know how it works, but you also don't care. You just know that if I do this, Windows will do something for me. Similarly with like any libraries that you use, right? Like it's like a lot of libraries are not open source. You don't know what they do. You don't know how they do it. You just know that you give it something and it'll give you something back. And of course, you know, web APIs have all this like all the time, right? So like a web API is just an API where interactions are mediated through network clients. And if you don't know what that means, go back to session 1. So requests are sent to a URL, sometimes also called an endpoint, right? And then something behind this URL will receive your request. It'll do some processing, and it'll return you back a response through the internet, right? And so you'll often see URL. You'll also often see URI, They're related, but they're slightly different. URI stands for a universal resource identifier, and a URL is a universal resource locator, which is basically a URI that also says how you're supposed to interact with it. So, for example, the website that you're on right now, https://www.twitch.tv/we'll-do-it-live3, is a URL. The HTTPS part specifies that you interact with the URI part, www.twitch.tv, through the HTTP interface, basically. Through the HTTP protocol, not interface, protocol. Yeah. And that's really all that an API is. They're not very magic. Like, if you have difficulty like conceptualizing it, you can think of it kind of like a power plug, right? You have the power plug, you have the holes in the power plug, and you know that if you put a thing into it, you get power. How do you get power? You don't know. Do you really care? But you get power as long as you have a thing that can interact with the interface, the physical interface of the power plug. Okay, so distributed systems. And distributed systems are really dumb, basically, and we'll see why. Wikipedia defines a distributed system as a system whose components are located on different computers, and each computer communicates and coordinates their actions by passing messages to each other. So, for example, if you have a single computer like you're doing now, your processes can talk to each other just directly through memory or something. If you have separate computers, then you can't do that. You have to like connect them across like an intranet, not an internet, an intranet or something. And you do this because single computers don't have the power to solve a problem by itself. And that's really it. So you scale out the power of your system by just adding more and more computers to it, like a supercomputer. So distributed systems are stupid. Let's just get this out of the way. They're stupid. And there's many, many reasons for this. And you don't have to read all this. You just have to know that they're stupid. And number one is computer hardware fails at a statistically significant rate. Hardware fails all the time. All right? Like, I had an incident this past, not last week, but the week before that, where where we run a bunch of tests, and the one computer that my specific test was running on just decided it wanted to commit Sudoku. It just died. Why did it die? I have no idea why it died. Like the thing just went completely offline. Why? I don't know. Like, it's not my test. I just reran the test on a different computer and it worked. But it killed itself. I don't know why. So when you have systems with multiple computers, the first thing that you need to do is you need to be able to handle completely random, completely unexpected failures across your entire stack, no matter what. Because your system will just kill itself. A node inside your system will just kill itself randomly at any point in time, and that's something you must handle. Yeah. And like the second problem is like you have systems that communicate with each other across some sort of network, and networks do not have infinite bandwidth. Like this is a bottleneck in your communications. If you pass too many messages, then the message that you expect to receive at an end will just sometimes not show up at all. So you have to be able to handle just like dropping random packages. And finally, like, you can't assume that your system is completely homogeneous. What this means is that if you have a system with multiple computers, you can't assume that all the computers are exactly the same. you can try to you can try to build your stack like that, but you can't assume that it's going to be exactly the same. Like it's just not possible. Okay. So this network bottleneck part also leads to this, that nodes inside your cluster have inconsistent information about the state of the world at any given time. Right? You don't know what you don't know what your system looks like, just ever at all, at any point. Just let's see, and because again, networks are bound by the speed of light, there is some latency between communications, and this communication delay also injects uncertainty into like just the state of the world. If you have two computers and they need to like talk to each other, say I have this and I have this, and we want to synchronize it with each other, that is almost that's just like that's not a solved problem. Like just because like there's an uncertainty in communication. And this and my computer is so laggy today. What the hell? Like, if you have a distributed system, you cannot assume you have consistent information ever about anything at all. You don't even know if computers have the same time. Like something so simple like, oh, it's this time. Like computers can't even synchronize that. This is formalized in something called the CAP theorem. Really is the fundamental theorem of distributed computing, which basically says when you have a distributed system, your system cannot be both completely available and completely consistent at every point in time. I thought you were blow drying your hair. No, I think it's a leaf blower outside. I don't know. I live next to a bunch of trees. There's always leaf blowers outside. Okay. So modern systems must take all of this into account. Nowadays, when you have like Google scale websites, something like that, they always favor availability over strong consistency. Like you ever had a problem where you sent a request like or something, and then you get redirected to a new page and your request is not updated, right? You have to like refresh the page a couple of times until you can to see your update. That's what this means. Modern systems always favor everybody can see the website over everybody has the exact same view of a website at all times. Because of the CAP theorem. You can't have both. You must have one or the other. And the websites always favor availability over consistency. But of course, you can't just have like completely random information at all times. You have to like be able to be able to synchronize eventually, and that's what weak versus eventual consistency is. Eventual consistency is your changes will always be shown eventually. You don't know exactly when, but eventually it's going to show up. And that's what refreshing the page to see means. Versus weak consistency, which is like there's no guarantees about anything ever. And weak consistency is like it's obviously easier to implement because you just don't need error handling, right? Like okay, whatever, things happen. Like this isn't bad. It's used in streaming. It's used in like when you're like chatting with people, online games. Like when you see I don't know, when you see like people like skipping or jumping in like an MMO or something because like you're lagging, is because you didn't get the packet that this person is moving. But the game doesn't care. Like the game can just handle it. Like because it's okay to just drop a little bit. Because if you don't handle this, then what would happen is, well, you need to wait for the package to come in, and that introduces more latency over time to your system. So in streaming, in like games and things like that, weak consistency is preferable. Modern systems are also designed for scalability. The ability to handle completely unexpected and very rapid increases in traffic. You go on Reddit, you know, some website goes viral and then they crash, the Reddit hug of death. That's what this is. That system was not designed with scalability in mind. Also, of course, you need to scale down after the traffic is passed. You don't want to keep paying for servers. You don't need it anymore. You need to be able to bring in lots of servers quickly, and then also drop those servers when your traffic is passed. This is not chaos engineering. This is scalability and chaos engineering are different things. So, modern systems also use this thing called a microservice. Like people don't really understand microservices. They just try and use microservices without using it. A microservice is just, you have a single application, and this application could do lots of things, right? Like, let's see, like, we'll think about like Uber, right? When you download Uber or something, you have a single application on your phone, but Uber does a lot of different things, right? First of all, it has like authentication. Authentication is almost always a separate microservice by itself because everybody needs authentication. You have the like profile information, which doesn't need to be synchronized with drivers, with like, looking for drivers or something. You have like your status, like these things don't need to live in a single machine. They could be split up into separate domains. Microservices then create a system, a distributed system of distributed systems, because a microservice is also a distributed system, right? So, and this has benefits primarily for scalability, right? So if one system is a bottleneck, for example, authentication, because everybody needs authentication, you split authentication off into a little separate thing, and then you can scale just the authentication part independently. The other, and this is really the primary benefit of microservices, is business flexibility. Okay, microservices are not an engineering benefit, do not have very many engineering benefits. They have business benefits, because now when you have microservices, you have clear owners of a certain section of the business, right? This allows your business to grow. This allows your management to have a more coherent view on ownership. This is the primary benefit of microservices. You do not make microservices for performance reasons. In fact, microservices decrease performance because it's a distributed system of distributed systems. Every system needs to be able to handle every single failure case again, and just the process of communicating between microservices introduces more delay, because now you have the network latency between each of them. It also drives up complexity because one distributed system is already complex. Now you have a distributed system of distributed systems. It's just like there's the meme video. There's the meme video of a guy explaining why we can't add like a birthday to a product manager. It's a great video, and it's about the title of the video is just called Microservices, so you can go look that up. But that video is basically just like microservices done wrong. Okay, the problem is people think, oh, Netflix does microservices, Amazon does microservices, we should be doing microservices too, without understanding that a microservice is a business benefit, not an engineering one. Okay. As you build your application, you eventually hit the point where you see a bottleneck that needs to be scaled independently. or your business is growing too much. You like one manager cannot manage like 40 engineers or something. So you need to be able to split up the business properly. That's when you go to microservices, not beforehand. Only switch to microservices once you see the pain. Okay. So that being said, a modern system is not like particularly complicated to like think about, right? This is a system. This is really what a system, like a very like high level Pepega view of what a system is, right? Here's you. You want to access the system. The first thing that your Pepega does is you talk to a load balancer. A load balancer just balances load between each individual server to make sure that one server is not overloaded. And your servers do some sort of processing, right? Your servers needs to run some sort of code, and that's run on some server. And then your servers need to talk to some database, which is somewhere. And then okay, your server talks to your database gives you the thing back, and then your server just says, okay, Pepega, here you go. Like, it's not conceptually difficult. The devil's in the details in these things. So, yeah. And that's, yeah. And this is just a recap of exactly what I said. Load balancers distribute requests to make sure no one server in the cluster it fronts. This is called fronting. This load balancer is set to front the service to make sure no one server in the cluster it fronts is overloaded. Servers handle the actual processing of the request. Like, load balancers don't care. They just say, okay, this guy is free, you can have it. Servers do the run the code. It's whatever. And databases store shared data that can be accessed by, and only by, this part's important, only by the server cluster. How difficult is it to have your software change to microservices? That depends on your service. I can't answer that question. So, databases. So important, they get their own title. Like, if you have a web API, your database is your application. Okay, your servers generally don't do much besides reading and writing to your database. And then obviously, like, once it's in a database, like, you have to be able to do something with it. So maybe there's more afterwards. But that's like an asynchronous part. Your database is your application. When you use the term database in engineering, there's actually two different ways of thinking about it. One is a set of related data and how it's organized. It's just like your data. Okay? The second way of thinking about it is the underlying database management system, which is software that can query your actual data itself. So DBMS, I think generally when you say database, you refer to the DBMS. But again, databases can be categorized by how data is related to each other and the engineering trade-offs in their design. Like, CAP theorem again applies to databases because one cluster cannot support your entire application. Like, you think Google has a single, like, I don't know, Intel i9 fronting all of Google? Like, no, they have a distributed database. So they need to be aware of the CAP theorem. They need to understand the engineering trade-offs and how their databases are designed. Right. The most popular databases are called relational databases, which were first formally described in 1970. When you think of when you just say database, the first kind of database that people think of are relational databases. Data is organized into tables of columns and rows. So if you're wondering, yes, Microsoft Excel is a relational database. It's got tables of columns and rows. Each row is an entry, each column is an attribute, kind of like Microsoft Excel. But the fancy part of relational databases is that you can have tables. Your tables can refer to other tables, and these tables can then be joined together to create composite tables, to create composite data that you need. Cool. Oh my god. Okay. So some of the trade-offs that relational databases make is that because they were first formalized in the 70s and they were made popular in the 80s, during those days, CPU is cheaper than storage back in those days. Relational databases, data design, generally prefer splitting data across tables and removing redundancy to lower the storage pressure on your database. This is called normalizing your data. They also, because of this, but because you're splitting data across tables, queries can get very complicated in a relational databases. They heavily depend on optimizers to speed up your data access. Optimizers and like indexes and like very complicated things to speed up your data access. Relational databases generally also favor strong consistency over availability, right? This is true in general. Like it can be tweaked, but like Postgres or like Oracle databases, like they prefer strong consistency. And of course, because of the CAP theorem, that means they compromise their availability. So, like I said, relational databases were specified in the 70s. So technically, NoSQL databases came before SQL databases. But they only started becoming popular in the early 2000s based on the needs of these massive warehouse scale web companies. I think Amazon published their famous Dynamo paper in 2004 or 2006. I can't remember which. When you're at this scale, the relational database trade-offs are unacceptable. These are unacceptable when you are at Google scale or Amazon scale. Okay? So they needed a different way of thinking about databases, which is what like the Dynamo paper is about. Today, there are many different types of NoSQL databases based on their data models, and some of them actually do use SQL. So it's kind of a bad term, but it's whatever. These different data models are specialized for different workloads. So, like AWS loves to talk about, oh, you need to pick the specific database for your application or whatever. It's like, do you really need it? It's like, is that enough question? So the trade-offs that NoSQL makes is that in modern days, storage is much cheaper than CPU. Okay, Moore's law is done. It's over. CPUs are not getting significantly faster anymore. That's just a fact of life now. Storage is still getting cheaper though. So like in the 1980s, I believe Intel first released the 8086 processor in 1978, and that had a clock speed of 5 megahertz, and that retailed for $1,500 adjusted for inflation today. The modern 3.5-inch hard drive was first released in 1983, and that had a capacity of 5 megabytes. 5 megabytes, and that retailed for $5,000. Okay? Nowadays, the Intel i9 whatever costs like $500-$600, and a modern consumer hard drive costs around the same for 16 terabytes. Hard drives have improved by like 40 million times in past 40 years, whereas CPUs have increased by like 1,000. Yeah, storage is much cheaper than CPU nowadays. We need to lower CPU pressure as much as possible, so we cannot have complicated queries. NoSQL databases do not have complicated queries. They one table, okay, just give me the data. Just give me the data. I don't care. Just give me the data. So lower CPU pressure. They almost all favor availability over consistency, unless you're MongoDB. MongoDB doesn't do anything. This generally also has positive implications on access speeds. Again, lower CPU pressure. So because of that, most have eventual consistency models. And this is just a consequence of being non-relational, is that in general their data models are simpler to wrap your head around, I think. But like the question about all this is, do you need a NoSQL database? And technically the answer is no. Generally, no. You don't actually need a NoSQL database. Do you require sub-millisecond latency across sustained loads of thousands, tens of thousands requests a minute? Most people just don't do this. Most people just don't care because their application is just not big enough. Doesn't have enough traffic to require a NoSQL database. And so you're perfectly so like the RDB relational database trade-offs are just perfectly acceptable because you don't care, because you're not Google, you're not Amazon. Is GraphQL NoSQL? No. GraphQL is a terrible name. It is not related to this at all. Which isn't to say it's useless, it's just not related to this at all. But a second consideration that you have to make when you're choosing between SQL and NoSQL databases is that my fucking computer is do you have a database administrator? Because relational databases are all run on servers and they all require constant uptime. Go back to session 1. And there is a reason that database administrator is an entirely separate job family from software engineer. They have completely different skill sets. They have completely different specializations. Relational databases are massively complex. Like all this stuff, I don't know how to do any of this stuff, okay? I'm not a database administrator. I don't know how to do any of this stuff. Okay, in general, NoSQL databases are simpler to operate. So that's a consideration that you have to make when you're designing your application and what database that you kind of want to use. What about managed databases? Like, yes, managed databases exist. For example, Amazon RDS exists, and it handles lots of these things for you, but you still have to know how to do it. Like, there's like the only fully managed database that AWS has is DynamoDB, which, spoiler alert. Okay, so our API is going to use Amazon DynamoDB because it's fully managed. I don't have to do anything with DynamoDB. I don't have to care at all about anything. I just have to put data in and get data out. I am not qualified to teach anybody relational databases. I can't do it. I'm not even going to try. Okay, but like for our load balancer, again, we're going to use Amazon API Gateway because it's serverless. Like Elastic Load Balancer, Elastic Load Balancer also exists, but it's more complicated than API Gateway, and API Gateway is also just as complicated, is just like so much complicated too. We don't I mentioned that I want to keep costs as low as possible. So we're going to be using Lambda for most of our compute. There's Cosmos DB. Okay, well on Azure, I know there's Cosmos DB. I've never used it. I've never used Azure. If you want to use Azure, then I guess Cosmos DB might be okay for you. I haven't evaluated it. I work at Amazon. I use Amazon API Gateway. I use Amazon Lambda. I use Amazon DynamoDB. This is standard implementation inside Amazon for basically all new applications. And if it's good enough for Amazon, it's good enough for you. Yeah, this is just standard. I'm just teaching. I'm not teaching anything like crazy. Like, this is just standard. Everybody inside Amazon uses this. So let me go get some water real fast, and we will start coding. Downside of managed DBs is vendor lock-in. This is true. This is true. However, you have to make the engineering trade-off. Do I want to take the time to do all the database management myself? Because like I said, it's hugely complicated. It's massively complicated. So if you have the resources, then do it yourself. Fine, that's okay. Otherwise, like, you know, you have to consider, like, is it worth my time to do this? Surely it depends on your needs. I don't know. Like, if your need is not vendor lock-in, then sure. Otherwise, do you really care? Someone has Amazon stocks? You bet your ass I do. You bet your ass I do. Someone's getting a raise? I've already gotten a raise several times. Like, I need a bit more. I'm not getting promoted to senior for like another year, so I don't know, maybe. Okay. So one thing before we get started is that I did make some changes to the pipeline. If you guys watched last session, I did something very bad. I made it work. I made it better. Okay, I made it better. Give me some? No. No, they're so expensive. Amazon stocks or shares are so expensive now. It's ridiculous. Okay. Okay. Where did I put it? Where did I put it? Is it this one? Yes, it is. From my experience, there's nothing wrong with working directly with the DB itself. You sure you may need deeper understanding when you hit performance issues, but you should only be concerned about those performance requirements when you hit those limits. I agree. Like, okay. The question is, like, if you have like a small application that nobody cares about, then fine, go ahead. Use, like, you can use AWS calculator. Let's just go back to this. AWS calculator. You can use, like, you could, like, stand up a server. You can stand up a database on EC2, and that's fine. Like you can use the smallest instance type available. What even is the smallest instance type available? You could use like a micro for no cost at all. It doesn't matter because but the question is, like, do you care? Do you see yourself getting to the point where you do see those performance implications? Then you do need specialized help. Are you going to do it, or are you just going to use managed? Like, it doesn't matter to you. It doesn't really matter. It's the trade-offs that you have to make. If you're using open, like, it doesn't matter. Like, yeah, it's your engineering. It's your application. Like, if you really care about vendor lock-in, then yeah, don't use DynamoDB. It's up to you. But me, I don't care about vendor lock-in right now. I just want to get a database and I want it to be working and performant without me having to do anything. And I will show you just how little you have to do to get DynamoDB up and running. Okay. We'll call this backend stack.ts. So import star as CDK from at AWS CDK core. Export class backend stack extend CDK dot stack. Constructor app CDK dot app ID string. Props, I believe this is CDK dot stack props. Super ID props. Question mark. That's not BKQ. That is also not true. SQL implies a relational database, which yes, does imply schema, but NoSQL databases also can have schemas as well. Like, it's just relational versus non-relational. That's the entire trade-off. And if you really care about relational databases or about the relational model, that's like mathematically defined, so you can go look it up on Wikipedia or whatever. Okay. So I guess the first thing that we should do is just give me a DynamoDB table, render table. Import star as Dynamo from at AWS CDK AWS DynamoDB. Wait a minute. Package.json. AWS DynamoDB. What else do I need? API gateway. I need Lambda. HIJKL, okay. I also need, do I need logs? Maybe I don't need logs, okay. npm install. Python rants when we get to Python. Be patient, we're almost there. We're almost there, turret AA12. We're almost there. Can we zoom in the code? Sure, we'll see if I can zoom in the code. Is this good? Since when did building systems become mainly modifying JSONs? I mean, when infrastructure as code became popular. I don't know when that was. Private render table equals. Do I need to save it? I think I do need to save it actually. So private Dynamo Dynamo table is a Dynamo table. This. What do we call our table? I don't know. We'll just call it blogs table because I guess I'm making a blog. I'm making a content management system, I guess. Okay, so I only need to add one thing, and that is the billing mode. Dynamo.billingMode.pay per request. What the hell is the problem with this? Oh, okay. I need a partition key. Fine. I need two things. I need a billing mode and I need a partition key. Type dynamo dot attribute type dot string. Okay. So, what does this do? This just says that instead of paying per capacity, I pay per request. So I do the serverless billing mode for this Dynamo table, and my partition key, which is like a partition key, you can kind of sort of think of it like a unique, as like an identifier. It doesn't have to be unique though, is the point. Like as you put more things inside DynamoDB, partition keys tell Dynamo how it should split up your data so accesses can remain pretty fast. Is this using Dino? No. I'm pretty sure this is run using TS Node. Or Node TS, I can't remember which way. So yeah, the only thing I need is an ID. I can give it something else. I can give it like a sort key, which will help me when I'm running my queries. And so for that, I think creation time is usually good enough. And this is also, this is a number. Why is prettier not working? Oh well, who cares? Okay. And that's it. I don't have to do anything else. Like this much code, this sets up a table that handles replication, it handles backup, it handles failover, it handles everything for you. Like you want to deal with all that sort of stuff, go ahead, but like I don't really care. And again, like I said, at Amazon, everybody uses Dynamo. If you want to use a relational database in Dynamo, you have to like if you want to use a relational database inside Amazon nowadays, you have to like go to your vice president. You have to give them like a huge document about like why Dynamo cannot meet your requirements, and you're gonna have a lot of people looking at this document and asking you very tough questions about this, because like they're just gonna tell you like most of the time you just say no, Dynamo can meet your demands. Just don't do it. Okay. And now, like I said, we need an API gateway to handle our load balancer. And this also should be an instance variable, I think. Star as API gateway from API gateway. The hell? Unknown mark. I don't know what that means. Of course, Amazon wants you to use the products. No, it's just like they don't want you to have to deal with, running a relational database, because Amazon hires lots of relational database experts, and they know that running a relational database is really fucking hard. So just like, why bother? Why do you care? Like, if you want to run Amazon also runs relational databases. Like this is what this is, Amazon RDS for Postgres, but they're telling you don't do it because it's too much work. I believe it's a REST API. How often do you write things from scratch like this at work? Never, because inside Amazon we have templates that stand up a basic stack for you. It's like, okay, just use one of those. But like, if you want to like go into the details, then yeah, you do this all the time. Like a lot of my work is just going into things like this and just like making updates to like, to add features or whatever. I believe this dot render, I guess we'll call it render API. Private render API. this dot API equals new API gateway. I think it's just REST API. Should probably look at the documentation. AWS CDK API gateway. Like writing things from scratch, it's like no. Like I said, this is standard implementation. We have the internal tools team who have written this up for you, and you can just like we'll just generate a package that has lots of these things with their default configurations. And it's just good enough. This and what do I call this? Probably call it a HealthyGamer workshop API, I guess. Props doesn't mean anything. Okay. This is enough to create an API gateway and a database. Now we need a few more things, right? We still need, where is it? We still need this part. We still need the compute part. And this is where most of our time is going to be spent today. Is integrating our load balancer with our compute and our compute with our database. Okay. AWS Lambda backed APIs. I don't really like this because it's like I like having more control than they let you, and so I prefer just using the raw REST API. So how should I do this? I guess we could just create a Lambda function then, huh? What's the best way to start? Okay. So most web applications are called CRUD. C-R-U-D. It's not a pejorative, it's an acronym. It stands for create, read, update, and delete. Maybe it is a pejorative because it's just like so boring and basic, but it is what it is. Most web applications are CRUD apps. They do create, read, updates, and deletes. So I guess we'll start with the read because the read is the simplest. You just look at a database and just return whatever the database gives you. So this dot render list function. I don't know. Call that. Why did I do it that way? Render list function. It's just code. We always change later anyway. It doesn't matter too much. So use Lambda function. I want to create a function. Supplied file is blah, who cares? So what do I need in a function? Const list function equals Lambda from FD. What the hell? So bad at typing. New Lambda dot function. Call this, call it list function, because I am terrible with names. What do I need? I need some code, I need a handler, and I need a runtime. And that is all that is required. Okay. Start with runtime because be lambda.runtime.python. Ugh. This kills me every time I have to do it. Because where did I put it? Because you people voted, and I'm doing what you people wanted, at 43.9% of the people wanted Python. So I'm gonna do it. This isn't the rant yet. This isn't the rant yet. We're not there yet. So I'm gonna do it. I'm gonna do it. But I'm not gonna be happy about it. Okay. What do I need? Okay. So I guess now actually is a good time to talk about Python, maybe. We'll just leave it like this for now. Code equals undefined. Oops. And handler is undefined. We'll just leave it like this for now. It's not going to compile, but it's fine. Let's back up. I've already created the backend thing. There is nothing in here, actually. Let's back up all the way. If you're doing it in Python, why are you writing TypeScript? Because while CDK lets you write Python, I don't need to write Python if I don't want to. That poll was only for the backend code. It's not for anything else. Windows terminal. Give me 1 second. Okay. So I've never written against AWS Lambda. I understand the whole point of serverless, but what was the TS code for? This TS code generates a cloud formation template. It created this, right? And this is infrastructure as code that lets you define your AWS resources. What's my preferred language? Not Python. That's all I can tell you. I don't really have a preferred language, it's just not Python. How do we get started? Okay. So in Python, if you have lots of Python files, you have to create a module. And to create a module, you create a directory. And in that directory, you create an init.py. And now, blogs is a Python module. Yay! So now I can put like crap inside blogs and I can reference it as blogs. I also need some third-party libraries, and to do that, in Python in general, you call that requirements.txt. Inside requirements.txt, we're going to use Boto3. And Boto3 is the AWS Python SDK. Basically lets you talk to AWS stuff. Why is it called Boto3? I don't know. I have no idea how anybody names anything inside Amazon. But what does Boto even mean? I don't know. Okay. And we also need a handler.py. So inside handler.py, we need a few things. Import JSON, import logging, JKL, yeah. There's a couple things that we need. Finalize response, body status code. So when you have an API gateway, API gateway needs some way for it to map responses to like error codes and things, and also like if you want to add like custom headers to your response, like who's allowed to access this, then you either do it inside API gateway itself, or you can just specify it inside your code, and that's fine too. Status code, status code, status code. Header, and header, you usually just add access control. This is like the default. Access control, allow credentials. Oh, this is true. And body is you just dump your body. You dump your body. JSON.dumps body. Chat overlays in the way, cannot see some of the code. Well, I either put it here or I move it here, and you can't see the chat because this is a white background. So I don't know. I had it the other way around. I don't know what's better. Like, it's okay to not see some of the code. It doesn't matter too much. And we need a handler for our Lambda function. A handler is an entry point that Lambda will call to run your function, basically. And I guess we'll just call that list. And when you have a Lambda function, Lambda handler always has two inputs. It has an event and it has context. Now, context has things that you don't really need. You give this Lambda context. You never really need it. So it has things like, what is the name of my function? What is the arn of my function? Yeah, things like that. Like identity, we're not using Cognito, so I don't care. Like you don't really need to use it. Get remaining time in milliseconds. Well, that's a little important, but again, doesn't really matter because you don't care. You generally don't care. Event, however, is important. Event is the request that is sent into your pipe, into your Lambda function. Maybe don't call it list as you're overriding the built-in type list. That's a good point, I guess. So, yeah. In that case, so just body equals. I usually just call it a list handler event. You very rarely need to pass in your context, and if you really want to use like unit testing, it's easier to test if you separate out the handler from itself. Return finalized response body 200. Okay, so list handler does not exist. We gotta add that. What do I call it? What do I call this? Again, I'm just so bad with names, man. I mean, it doesn't really matter, so call it list handler.py. Okay. So here we need import Bodo3. We need our operating system. We need import OS. I think that's all we really need for now. Def list handler event. So here's the question. What does our event look like? What do I need to list things inside my database? So the answer is I only need one thing, and that one thing is actually optional. And that is what's called, there's a lot of different things that people call it. Sometimes it's called a token, sometimes it's called a key. But it's like something to tell that you give to tell you where you last were, because you're not like, if your database is huge, you can't like return 1 million events in a single response. You have to like chunk it up a little bit. So you have to tell your database where you last were, so it can start from that point. So I suppose in that case, you know, we'll just call it like, I think in AWS it's like, it's inconsistent what they call it. Sometimes they call it like token, sometimes they call it like a key, like we'll just call it token. So event dict, I guess we'll call it dict. Does that work? I don't know anymore. Who cares? It doesn't even matter. Like, it's so worthless. Dictionary string. I don't even remember the syntax for this. Event next token can be null. That's it. I don't know. Python's type handling is so worthless that it might as well just be a comment. This is basically the same as, you know, Python's type handling. It's completely worthless. Orgs. Okay. So if we have a DynamoDB table, the way that you list a whole bunch of things inside your DynamoDB table is called scan. First of all, DDB equals photo3 dot client DynamoDB. Great. Now inside DDB, I could do DynamoDB requests. So let's take a look at that. Photo3 DynamoDB scan. It has type annotations. Yeah, but type annotations are worthless. They are not enforced. They're just not enforced. You want me to show it to you? I can show it to you. Python def fuck you two, 3, 4 return a plus 2. Fuck you 2. You see this? Unsupported operands for plus, int, and string. It doesn't catch the fact that I put an int in here. It only cares when I try to use the int. Type annotations are worthless. That's just the beginning. Like, okay, we're gonna be talking more about Python. Like, I need to talk more about why Python is bad when I need to start using pip, and that's when it's gonna really start. Like, I hate pip so much. Okay. So DDB scan. The scan operation returns one or more items and item attributes by accessing every item in a table or index. To have DynamoDB return fewer items, you could provide a filter expression operation. That's okay. I don't care. This is gonna be a dumb scan. Just give me everything. So request syntax. So like I said, next token can be null. So I need to split this up into keyword arguments. Quarks. What a stupid name. Quarks. Who the hell thought of a quarks? So table name. What do I need? I need a table name. I need to tell Dynamo which table I want to scan. And I'm not gonna pass that into my event. I need to store that as an environment variable inside my Lambda. We'll see how to do that later. So I need to use OS. I need os.environment variables.get. Oh wait, no. This must exist. If this doesn't exist, this is a failure. This is a failure. So it must exist. So I have to use the. I'm going to use the angle brackets. Limit HealthyGamer blog. Where's the HealthyGamer blog? Oh my god, this website doesn't exist. HealthyGamer.com doesn't exist. If you care about type enforcers, why use a dynamically typed language? Exactly, right? Why did they even bother adding it? Why am I using Python? Not because I want to. Okay, so the HealthyGamer blog has 1, 2, 3, 4 things. Okay, so we'll limit to 4. Fine. Just, who cares? And because next token might not exist, if event dot if how do I do this? Next token in event quarks. So in Dynamo, it's called exclusive start key. Exclusive start key is your next token. So we'll just call it exclusive start key, next token. Oh wait, no. Keyword args exclusive start key equals event next token. What are you complaining about? Nothing. So items then equals ddb.scan star. Who thought of this syntax, man? Who thought of star quarks? What is this? Okay, now I'm going to define request and response models. Like what exactly? We're gonna like make that concrete. But for now, I don't care. So we'll just return items. I think that's it. So we'll make this more concrete later, but for now, we'll just make it as stupid as possible. And here we go import, what the hell did I call it? From blog, what the heck did I call it? Blogs dot list handler, import list handler. What's the problem with you? Unresolved import. Can I just do this? Can I just do this? Okay, I guess that works. Why does it not work when I add the module name? I don't know. Python's module import resolution is like the dumbest thing. Is actually the dumbest part about Python. It's so stupid. It does nothing. Why do I even have init.py in it? God. Explode. Like, okay, star is explode. Who, like, what? My first, like, I'm a math guy. When I see star, I think exponents. Exponentiate your keyword argument. What? Why do you care so much about type enforcement anyway? Just don't pass it in. That is harder than it sounds. That is harder than it sounds. Okay. So I guess now we'll go back. What am I doing? Let's see. What am I doing? Ay. This is gonna take forever to compile again. Okay. Stupid bird, shut up. Star is also exponents in Python? I know, right? What even is this bird? What kind of noises is it making? So I need to get Python code. Python code. Lambda code. Implemented by, what do I want? Asset code. Yeah, I want asset code because I'm not inlining. It's not coming from CloudFormation parameters, and it's not coming from S3. Operator overloading. I mean, like operator overloading. The only thing it does is hide, what exactly you're doing. There's no like If you're adding numbers, fine, whatever. But like operating overloading, generally don't use it. I don't use it. Okay, so I need asset code. So Python create asset code. It's not really a render in this case because I'm not rendering anything. I guess we don't need inputs right now. Is this a void or is this? I guess we'll just return it. Lambda.code. What the heck is it your problem? So this dot, oh wait, no, return lambda.code dot, excuse me, what was that? See, from inline, no. From bucket, no. See, static asset, no. From asset, this is probably what I want. From asset. So first thing is a path. I guess import. Oops, import. Is it star as path? Yeah, star as path. From path. Path dot. I want to join because from where I am right now. So dir name is just a compile time macro. I think it's a compile time macro. Maybe a runtime macro, who knows. Go back to, it's in backend. And blocks? I guess it's the entire thing, right? I guess it's the entire module that I want. Do I need anything else? Asset options. Do I need any asset options? Asset hash, don't care. Bundling. Executing commit. I don't want to do that. Symlinks, don't care. Exclude, nope. Okay, don't need any options. Great, cool. So code, we'll just use this. This dot create asset code. And now my handler was inside handler dot. It was in handler dot py, and we called it what? List func. Called it list func. Unreachable code. What? What the hell is this unreachable? What am I even doing right now? Oh. Syntax error. That was a word syntax error. Okay, well, it's just a element implicitly has any type because type of global this. What the fuck? Who cares? This will get updated soon. Let's see, lambda code. Yeah, I solved that. I don't know if your code was. Okay. I don't know. Vim is just kind of stupid. It doesn't like to update. Maybe I'll just retry it. Vim is kind of dumb sometimes. Oh, in that case, what did I actually call it? Handler dot list function. Okay, it's fine. Handler dot list function. Do I need anything else? Okay. Oh, I guess we should give it memory. We don't need that much memory, so we'll call it like, I don't know, 256 megs. Doesn't have to be too much. Oh, and environments, like I said, we need to pass in the name of our table. So that has to be, what the hell did I call it? Did I just call it? I think I just called it table name. And that is this dot dynamo table dot. Is it just table name? Again, I don't remember. It is just properties table name. Yep, just table name. Cool. Now my Lambda function can access table name from inside. What the hell is the problem? Oh, that's why. My bad. Just not thinking straight today. There we go. Okay, what else do I need? So I need to give my Python function, my Lambda function, properties to scan my Dynamo table. Const list function execution policy equals new IAM from FL IAM HIJK. Oh god, I don't know the alphabet. Policy statement. We went over policy statements in the last session. DynamoDB dot scan. All I'm doing is scan, so that's the only thing it needs. Effect IAM dot effect dot allow and resources on the table. Dynamo table dot. This is the ARN. IAM policies always use the ARN, not the names usually. List function dot add to role policy. Cool. Oh, and this is something that you also need to do. This function dot where is it? Permission. So this add to role policy tells what this function can do. This function dot add permission tells what can access the function, which are two completely separate sets of permissions. One is what can I do, and the other is who can use me. And in this case, let's see, permission. What do I need? Add permission. Add permission needs an ID, fine. And in my case, I need API gateway to be able to invoke my function. And permission, inside permission, I need a principal. What's a principal? Implemented by all these things. The only thing I want is a service principal, which is an IAM, which is some IAM construct that represents an AWS service. Why they use SQS is beyond me. New IAM.service principal, and the name is just the service name. Okay, API gateway dot Amazon AWS.com. And every AWS service has a service principal. It's usually called the service name .Amazon AWS.com. If you're not sure, just Google search it. I just know this one off the top of my head. Kind of. Action, it needs to be able to invoke my function. And source arm. The thing that can use my function is my API. So how do I get the ARN for an API? We'll just search for ARN. I guess we use this, ARN for API. That's a method apparently, whatever. Oh my god, my chat is doing the Python rant for me. I love it. I don't have to do anything. Const. I mean, the whole point of power of Py import mechanics is that imports should not have power. Imports should just be, let me use the code. Why does it need to be more complicated than that? Like, anything else is just like confusing. Like, people, if you give people the power to do stupid things, they will do stupid things. And apparently the Python people don't understand that. And it just gives headache to people who don't like Python. I didn't read the chat. There was a whole lot of things coming on. Like, I was just like, okay. But I just see power of Python imports. Like, okay, why should imports have power? I don't understand. Why should imports have power to do anything other than just let me use the code? Okay, so I need my API to be able to integrate with my function, and you do that with it's called a Lambda integration. Integrates an AWS Lambda function to a blah 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 blah. Function integration. We'll just call it integration. It's too long. Integration. API gateway dot Lambda integration. What do I need? I need a reference to my function, which is a list function, and I need some options. What options do I need? Allow test invoke is actually very important, so that's the first one that comes up, so we'll just do that. Allow true. Anything else I need? Doesn't look like it. Proxy. Is proxy by default true? Proxy true. Yeah, okay. Well, let's just make that explicit. Proxy is true. I want it to be a proxy. Okay. How do I now add? Let's see. Is this your only complaint with Python? No. Are you kidding me? Of course not. I wouldn't say Python is the worst language ever created if, that was my only complaint about Python. Come on. It's kind of a minor issue in the grand scheme of things. It's not that I actually think Python is the worst language ever created. It's just like, there are obviously worse. It's just I don't like it. There needs to be more than just one reason like that. Okay. What do I need now? Where the heck did I put it? Okay, what do I need now? API gateway is pretty... VM is honestly frustrating to use, yes. Like, anybody, who thought virtual environment was a good idea? Like, what the fuck? Okay. So when you create an API gateway, what you're doing is like you're creating basically like a website. You're creating basically like a URI. And URIs have like these path delimiters. They're called paths basically. So that tells you like what sort of thing that you want to do. And you've obviously seen these before. We're on twitch.tv/we'll do it live 3. You're on my path. So it tells me Twitch, you're telling Twitch that I want to go to this guy and not Pokemon or whatever. Okay. So API gateways have the same thing. We have to, and that's called a method, I guess. Is it called a method? I don't know. So we need to do that. Let's see. Root.it. So it looks like I need to add a resource first. So I need to add a top level thing that I want. What's the best way to do this? Well, if I'm gonna have a bunch of functions that use the same resource, I might as well just factor it out. Like this dot render integrations, and we can just call list functions inside render list integrations. Private render integrations. I guess we'll call this return void. Not fucking up the syntax this time. So const root, we'll do it the way that they're doing it right here. Root equals my API dot root, and I need to add a resource. Add resource. I'll call that blog. And my resource is going to be, it needs to do at least 4 things: create, read, update, and delete. I guess we add like we can add sub resources. We can add resources to resources. So we add a sub resource to the root. So const list equals root dot add resource list. And now I can render a list function in here. I guess it's not a list function anymore, it's a list method because it has a whole bunch of things going on inside it. So this dot add list method, and we need, I need to pass in the resource now. So render list function, call render list method, and it inputs a resource, and that resource is called it's an API gateway. I'm guessing it's called a resource. It should be called a resource, right? Cool. Oh, it's not add list method. I call it so render. I mean, I'm not even looking at chat anymore. I'm just I need to focus on this. You guys can keep complaining about Python, and we'll get back to why Python is bad later. I love it. Okay. So now in my resource, now I need to actually hook up my resource to my function. Add method. I guess it's the add method. Method. So one thing, in like HTTP obviously has a whole bunch of different like methods. You know, your get, post, patch, delete, whatever. It has all this crap. When you're doing API gateway and your API gateway is fronting a Lambda, it has to be post. If you don't use post, it won't work. And this is like similar across the board for all AWS APIs. If you look at like what it's doing under the hood, almost every API except for like the S3 ones use post. All right, integration. I need to pass on the integration. So I just call it integration. And any what props do I need? I'm adding a resource, so it must be in this class. It must be add method. Add method. Options. Anything required? Not at the moment. Not at the moment. Is this everything that I need? Maybe. I think this is everything that I need in this stack, and this will create a load balancer, a table, and it'll create some serverless thing that I could run code on serverlessly. It'll run handler.listfunc. So I gotta hook this up now to my CI/CD pipeline. Oops. CI/CD pipeline. I really shouldn't do it that way. So yeah, I made some changes to the CI/CD stack from last time to make it better. So we need to extend the pipeline. Stage name. We have all this stuff already, so what do we call this? I guess we'll just call it deploy backend. Because I don't have a testing stage. Remember. No testing stage. If you have one, add it before here. And we don't have a testing stage because I'm cheap. Actions. I guess we start with a code build action. Code pipeline actions dot code build action. What do we call this action name? Deploy backend. Why not? Input. We'll have to change the outputs inside self-mutate, I guess. So we'll just call it self-mutate output. Output doesn't have to output anything, right? It doesn't have to output anything. Code pipeline actions doesn't have to output anything. Code build action. Interface doesn't have to output anything. Good. I need a project. The bird is back. Why is the bird back? Backend. Render deploy backend. Private render deploy backend. This creates a code pipeline dot code pipeline actions that what the hell do I what does this return code project returns a project. Whoops. Code build dot pipeline project. There we go. Next is some constructing too. Okay, so it's gonna be similar to this, right? Similar to this code project. Code build dot pipeline project. This deploy backend project. Props. What the heck? Build spec. Code build dot build spec dot form object. See, it has to be version. Why does it always do that? Version 0.2, magic number. Why 0.2? Who knows? Install. Okay, I guess we need to start talking about pip. Pip install. Text. Let's see, build spec environment. The environment will also be build image dot code build dot Linux build image dot standard 4.0. Okay. So return. Okay. So how do I say this? How do I explain in words why I hate pip so much? Why I hate Python modules so much? When you have JavaScript, right? Like JavaScript has, you can like compile JavaScript into a single file, and you can just deploy the file. And that's what most websites just use. They use one, maybe a couple if you like chunk it up to make it download a little faster. Python has no way of doing that. When you want to deploy a Python anything, you just have to give everybody all the code that you need. And if that's a library, you got to include the entire library. There's no way around it. So here for our Lambda function, we have our code, we have the handlers, but inside requirements, I said you also need Boto 3. Okay, so I need to install Boto 3 inside this directory, and I need to package all of this into my Lambda function. Yeah. So pip3 install requirements.txt is not sufficient. In fact, because of the way the syntax works, I think my preference is just take out all the bash stuff and just separate it out into a separate file, which is what I'm going to do right now. So we're going to do some bash scripting. Oh baby, I love bash. Hate bash so freaking much. Hate bash so freaking much. Deploy backend.shell. We'll call Romanet, who cares? Hate bash so much. Oh my god. Okay, setxe. Just always start with setxe. I don't even remember what the X stands for. I think E stands for like error out. If there's an error, you just fail out or something. I can't remember what X, but you always need it. Wait a minute. Do I want to do this here, or do I want to do this in my compile step? I mean, I'm compiling everything in my compile CDK step. Maybe I'll just put it all in the compile step. Fragile deployment scripts. I think I will actually just put it all in my compile step. We'll just make everything, put it all in here. So compile, what do I call this? Build code.shell. Just call it build code.shell, sure. Again, bin bash, you want to use bash, setxe, I don't even remember what X stands for. Okay. So let's take a look at our project directory right now. The top level is HealthyGamer Workshop, and it has backend folder, it has a CDK folder, and it has the license. We don't really care about the license. So what we're doing right now inside CDK stack is I'm going into the CDK directory, I'm npm installing, and then I'm synthesizing. So I guess we can do that. We'll start with that. Inside a script, you don't really want to use cd though. You want to use pushd popd. Pushd backend. So I guess we'll just start with pip installing everything first. Pip3 no cache. Should be self-install. Like somebody says, I need the R. Yeah, you're right. Forgot about that. R requirements.txt. Requirements.txt is inside backend, so you can just pull it from there. No deps, no dependencies. Don't ever give me any billion dependencies. Target. Okay, and target says, where should I install all this crap? I want to install inside the blogs directory, but I don't actually want it. I don't want it in the blogs directory. I want it inside the backends directory. I don't want it inside the blogs directory. And I want to put it inside a different directory so I could do some other magic. We'll just call it, so I'm inside backend right now. We'll just call it app layer. And we'll see why I call it app layer. Yeah. popd. I am now back in HealthyGamer Workshop. Pushd popd. So pushd CDK npm install. this is the install. We'll just set up as an install phase. Build phase. I'm still inside CDK, so I can just run my command here, npm run synth CDK synth. And I can't use this .stack name anymore. I gotta have to hard code it. That sucks. Well, no. Actually, I don't need to hard code it. More bash magic. More bash magic. Is it cache 1 or is it cache 2? I think it's cache 1. I think cache 0 is the file name. Yep. Okay, so back in this thing. Oh, pipe fail? Yeah. I don't remember anything. Why do I not want dependencies resolved? Because I don't need it right now. If I need it, I'll add it, but I don't want like a build. Like, you want this to turn into NPM? You want this to turn into NPM with installing every single directory like recursively? Like, come on, man. If I don't need to do it, I'm not gonna. Okay, so one thing that you need to do. Everybody complains that JavaScript is stupid. Well, you want me to turn it into JavaScript? Go ahead. Okay. Something that I had to do now before I do everything is that I need to make all of these files inside the directory executable. Because by default, even if you mark these as executable inside Git, code build doesn't care. You have to make it a manual step. And now in my build step, instead of doing this, I just run. What the hell? Because I'm inside, because I haven't changed my thing. I have to go to CDK, and I need to do what I call it build. What I call it build code.shell, and I give it this .stack name. That should work. Cool. So now, okay, let's go through this again. I'm in my base directory. I go inside the backend directory. I install everything inside requirements.txt into app/layer/ this folder. We'll see why later. And I go back out. I go into the CDK directory. I install everything that I need to compile my CDK, and then I synthesize. Cache 1 is bash magic. It just says you could pass in any amount of variables that you want into this. Cache 1 is just the first. Okay. So I don't need to do the install step here anymore. Wait a minute. Actually, I don't want to do this. Here, no, I don't actually want to do this, right? I have multiple. I actually don't care anymore. I don't actually need this. Whoops. And the reason is I have more than one stack now. I have the CDK stack and I have the backend stack. If I pass in what stack the stack name, it only synthesizes that stack. I don't want that. I want it to synthesize every stack. Okay, so just synthesize everything. Sorry. I don't need a install phase here anymore. I just need a build phase. And in the build phase, just execute cdk.bin.deploy backend. What do I have inside deploy backend? I don't have anything. I guess in this case, I kind of do want it to pass in this. This .stack name, because in this case I do only want to synthesize. I don't only want to deploy just the stack. Deploy cache 1. Cache 1. And because I've already synthesized everything in the previous step, I can just use those outputs. And that's with the -a flag. If this requires approvals, no, don't do this to me. Require approval, never. Okay, and now last but not least, I have to do the very bad thing that I did last time here. I don't have a choice, and we'll see why. I'll show you why we don't actually have a choice to do this very bad thing, but const cloud formation policy. I don't have a choice to do this. Like even like I asked some people and they just said, yeah, you don't have a choice. You need to do it this way. I have to roll policy. Yeah. What does this do? This says that this project can do anything on any resource, which is kind of what we need. Obviously, like the backend stack defines a finite set of resources. So if you really wanted to, you could enumerate all of them manually. Nope, ain't nobody got time for that, man. Even inside AWS, we just use ** when we're giving CloudFormation permissions. Like, ain't nobody got time for that. What else do I need? Do I need anything else? I guess we could just try this. npm run cdk synth. Let's see if this crashes. Looking good so far. I guess the Python rant arguments have died down in chat. That's okay. Can't continue forever. Oh, there it is. Oh, I know. Okay, so here's a problem actually. Bin CDK. Yeah, so I actually need to tell the CDK, hey, I want you to synthesize my thing now. Yeah. Backend stack app. Call it HealthyGamer workshop. Backend. Is this name too long? I don't even know. I don't need any props. Excuse me. Let's try resynthesizing again. That's true with a capital T, huh? Capital T? Why is Python the only language that uses capital T, capital F for true and false? I always forget this when I'm going back to Python. It's like, oh yeah, true has a capital T, false has a capital F. Okay, this is gonna take some time. I need to use the bathroom, so I'll be right back. Not even you have a response to that one, huh? Okay, so synthesized. They synthesized. They should be okay. Maybe. I don't know. Before we go, one more thing that I want to do. Okay. In here, there is one more thing that I want to do that I didn't. Let's see if I can find it. My notes. I need to open my notes. Okay. I'm going to do what's called a okay. So I'm going to create what's called a layer. What's a layer? An AWS Lambda function is technically just a Docker container. Like when you run a function, you're really just asking AWS to package your code into a container and then just run that. If you know anything about Docker, Docker has these things called Docker is built on layers. So you start with a base, and then as you keep adding more things, you create layers into your container. This and in Lambda, this is very similar. Like your code lives on top of the layers that you give it. So like what I'm going to do is I'm going to package all of the pip dependencies I have into this layer. And so my code can be just my code and none of my dependencies. I don't know if that makes sense. Like this is something you kind of need to do for Python, and really only Python, because every other language lets you just compile an executable. Even JavaScript just lets you compile an executable and just give you just one file. But no, Python's a special snowflake. Like, you can't do it. You can't do it in Python. And really, I guess this layer is going to be shared with everybody, so I don't know. Maybe we'll just do it this way. Create asset code. Const. Layer equals new lambda.layer version. This, we'll call it dependencies layer. I don't know. Okay, and what's inside? A layer obtainable from layer version. Okay, layer version. What properties do I need to give it? I need to give it code, compatible runtimes. It doesn't matter. I mean, just like, I guess I could add it, but it doesn't really matter. Code lambda.code. Again, it's going to be from asset. Like I did that. Path.join. Directory name. And again, we're going to go into the backend. And now I'm going to use the layer that I told pip to install into. See, like, you can find my code inside the layer. Inside this. Oops. Inside this. So package all of that completely separate from my code. I don't want to look at it. I don't want to see, like, it doesn't exist. It's just magic that happens because Python is a special snowflake. And I need to be able to access this from outside this method, so I need to call it base. So I just save it to this thing. Lambda.layer version. This base layer. And we need to pass it inside this boy. So layers. I believe it's a layer, so it must be an array. Base layer. Okie dokie. Cool. CDK npm run CDK. I mean, this shouldn't have changed anything, but let's just see. Let's find it right now. You can technically compile Python to a single DLL. Does anybody do that? Are you saying like use Python to compile it into a C executable. Like I don't think Lambda lets you do that. Well, you probably can because Lambda lets you run arbitrary things on it. But like, does anybody actually do that? No, because people use pip. Exactly. Nobody does it. Oh my god, what's this? Okay. Okay. So it's saying that there's nothing inside app layer right now. So I need to add something to app layer. What did I do here? Didn't do anything. It's fine. Okay. Let's see. PWD. Backend. So I don't want to add any of this to my Git repository. So I have to create a git ignore. Git ignore. Just ignore everything inside app layer. I think that's enough. And pip 3 install. We'll just install our requirements. It's fine. It's part of my build process. Oops. Pip 3 install. What was the command? I don't remember. I don't even remember anymore. Target. -- target. Yeah, so pip is Python's package manager. We talked about package managers in the previous session also. Just installing a bunch of stupid Python stuff inside app layer. Is this done yet? Why is it not like completing? ls inside app. Okay, get status. It's not and we ignored it, so it doesn't show up. Oh, another thing that is really stupid about Python about pip is that when you install a pip package, pip allows you to execute arbitrary code just because. So inside Amazon, pip is a security risk. We're not allowed to use it. And you shouldn't use it too, because you don't know what the fuck is going on inside here. You don't know if this is going to steal all your credentials. What the fuck? Who thought this was a good idea? Not even NPM lets you do that. And NPM is the worst thing ever created by humankind. Okay. NPM runs UDK. Like, this should not fail anymore because we solved the issue. It's whatever. I'm not deploying it from here anyway. I'm just testing it to make sure like it doesn't. I haven't done anything catastrophic. I have apparently done something catastrophic. CDK. Okay. So I got the path wrong inside my. My stack. It was inside backend stack. So I just forgot the second pair of backpacks with dots. Pulling any package technically allows rogue code to be executed in your application. It allows rogue code to be executed in your application, but pip lets you execute arbitrary code at install time, which is not when I'm running my application. It's like, I just want to fetch it. Just fetching it is a security risk. Executing random programs, that, yeah, sure, like, that's bad. But like, if I just want to, like, you don't know if pip ever gets compromised, if the Python package index ever gets compromised, then just pip install whatever will pwn your host. Who thought that was a good idea? Excellent. So this works. So let's go back. Git status. So I updated CDK. I updated the CI/CD stack. I updated package lock because I added a couple of packages inside package.json. I added these build scripts. These scripts. I added this new stack, and I added everything inside backend. So let's just do git add dot, because I just want to add git diff stage. What exactly did I add? Okay, I created this git ignore file. I created this handler.py. Added Boto3, build blah blah blah. Added this build script. Import and synthesize. Okay. I added all this. I hope it works. Well, we'll find out later. I added this new deploy backend project. It looks fine. It has no output. That's also fine. Package lock.json. Mercifully only has a few things. That's okay, whatever. And that's it. That's actually not a whole lot. Git commit. Session 3. First commit. Add backend. We'll call it initialize backend with API gateway, DynamoDB, and dummy Lambda. Update CI/CD pipeline to deploy back and git push. Okie dokie. Update, okie dokie, and our pipeline sees the commit. It's self-mutating. Let's just watch this run. I wonder if anybody has any questions outside of the Python rant. Because I haven't actually ranted about Python, have I? It was kind of muted. I had to let chat do it for me. Oh no. What is the problem now? Why did it fail? Stat code build output source backend app layer, huh? What? What? Is it really concerned that it can't find this? I guess it's trying to, that's really odd. I wouldn't have expected that. Okay, whatever. Let's see. What's the best way to go about fixing? Oh my god, this is where it starts. This is where it starts. Give me 1 moment. What did I even do? Wait a minute, aren't you supposed to call app.send? What? If I skip it, does it not matter? I'm a little confused right now. Oh well. Oops. Or did I delete it? I don't even remember. Combo breaker. Yep. God damn it. What am I trying to? What does this do here? npm run cdk synth cdk stack. It shouldn't care. I'm gonna need to update this artifact thing anyway, so I'm confused. Honestly, it's not really a combo breaker because this happened last time. So it would be a combo breaker if I didn't fuck up. And it worked on the first try. Honestly, that's the biggest surprise. If anything ever works on the first try, you get a little suspicious. Like, things don't ever work on the first try. Is this gonna fail again? Maybe. Who knows? Yep. That's okay. Okay, that's fine. I guess for now I can just add something. I believe in general we call it git keep. So bin.git ignore. What is the syntax for excluding a file? I don't remember. Git ignore exclude. Exclude folder but include specific folder. Okay, star, sure. App layer dot git keep. Git status. No, didn't work. So that's what I want. Let's see if this works. npm install takes forever. Oh, you gotta fail. Is it failing? Nope, didn't fail this time. It actually succeeded. Poggers. And now that kicks off the CDK deployment. Update in progress. Come on. Come on. I know you want to go. Let's go. Come on. Okay. It's creating a role for the deploy backend project. It's creating 4 different roles. What? I don't know, 2 different roles. Okay. They're created. It's creating an artifact bucket. Oh no, god damn it, not another artifact encryption key. Oh wait, no, it's just updating. Oh no, but this is still gonna take like 5 minutes because KMS keys take 20 years to update for some weird reason. Still updating. Still updating. Yeah, this is what I do. Like, a lot of the times when you make a change, you're just waiting for a deployment to happen. I'm just like, resident sleeper. Like, I just go off and like browse Reddit or YouTube or something at work while I'm technically during work hours. Just waiting for stupid things like this stupid encryption key. Let's have a chocolate. 70% cocoa. Oh, it's done. Oh my god, I was muted this entire time? Jesus. Yeah. Keck W. I was eating chocolate and I didn't want to do the ASMR stream, so muted myself but forgot to unmute when I was finished. God damn it. Okay. Okay, so the explanation that I had was we need to pass to deploy backend everything inside cdk.out because cdk.out has stuff that deploy backend needs. We also need to pass in the binary directory because deploy backend needs a script that's located inside the binary directory. And we also need package.json because we need to tell deploy backend you need to be able to install CDK. So package.json has that. I don't want to pass in all of node modules because all of node modules is like 10 gigabytes. Probably not 10 gigabytes. It's probably around at least 500 megs. So yeah, that's what I did. Everything inside cdk.out. This means recursively include everything. These explode / more explode means include everything. Binary is not a recursive directory. It's pretty flat, so just include everything in one level and package.json. God, this stupid website is can be so dumb sometimes. I remember like yesterday I was testing something and I somehow made this table like pop out and float over onto here. I don't even know how I did it. I was just clicking this and it just like the layout got so messed up. It was so weird. I think we'll have to release change again because this updating a code build project doesn't count as updating the pipeline. So you just gotta like release the change again. This is probably gonna fail. That's fine. But yep, there it is. Release. Oh, and the reason why here in self mutate, I get to split off the compile step and the deploy step from AWS CloudFormation is because the this stack has no external dependencies. Everything that I need to deploy the stack is defined here inside resource here. I don't need anything. However, the backend stack doesn't. The backend stack has the dependency on it has a dependency on this directory. It has dependency on the code. So CloudFormation is a little stupid. It kind of doesn't know how to do that. And the people who developed CDK kind of sort of messed up in that they didn't let you specify an easy way to do that as well. So if that doesn't make like what that means is like basically just means I can't separate these out. Like CDK does some magic that uploads all my code here. What the hell? It failed. Why the hell did it fail? No, it didn't. Okay. Oops. I'm in the wrong directory. Where am I? It's looking at the wrong thing. Yep. Okay. So yeah, remember we changed the outputs to be everything and be like a bunch of things inside the directory. It's not just the single file anymore. So I've got to update the path. And there's so much, like, there's a lot of things that I didn't have time to do. Like, we're at 2.5 hours already. I didn't get the chance to like type def the API gateway. I just want to like get the API gateway deployed to show that, you know, things do work the way that they expect it to. And then I think next Saturday is not a scheduled workshop day, but I think what I'm going to do is like, there's so many things that I could add here that I'm just going to do like a session 3.5 on Discord, and we'll just do some live coding without any, like, it's going to be a lot of failing, but it's like I need to add a whole bunch of things. That's not really relevant, so make an announcement on the Discord for that. Great. How do I disable this transition? I need to stop this execution. Yeah, stop it. Stop it. Because this is the old thing. Okay, stopped. Did I just mess it up? Or does it just take a while to update to reflect the status? Okay, there it is. Yeah, there it is. It's doing the right one. The right now. Good thing now. This should not fail. This should be template CDK. Yep, this is updated. Synthesized. Good. So let's see. Expanding CDK. Expanding everything inside here. Bin. Good. Found 112 files. What the heck? Why is there 112 files inside here? Come on, details. Okay. Update in progress, good. This should be quick because there should be no changes. Come on, it should be quick. Come on. Come on. Come on. What the hell is it doing? Okay, there it is. Update complete. Okay. Come on. Okay. Come on. Did I mess something up? Shit, keep doing this. Oh god. Wait. Did I? Ay. This is gonna fail. This is gonna fail. And it's gonna fail because it doesn't know what NPM is. Doesn't know what NPM is. Need to do that. Found list instead at line 5. What? What? Oh, god damn it. God damn it. Commands. Like, this is so dumb. This is dumb. I'm dumb. I'm dumb. I even had a sample to copy it from and I messed it up. I suppose I don't need to deploy it here. I could just tell CloudFormation to do it. That's whatever. The pitfalls of live coding. If I just copied my test that I know will deploy in one shot without me doing anything, it would be great. But I don't. I have to type it out live. Why do I do this to myself? Great. There's actually one thing I need to do. Damn. This is no longer CDK. This is just local directory. Build spec. It should just work. It should just work. I say, knowing that it probably won't just work because it never just works. This step should work. This should take like 30 seconds. Watch it run. Come on, why does it take so long? Why does it take so long? Why does it take so long? There it is. Okay. Let me take a look. Build details, so let me see. Okay, it's been updated. Wait, what? That's not what I want. That is not at all what I want. That is wrong. I did not catch that. Oops, undo. This needs to be... How do I do this? I'll just pass it in as a string. So I can never remember this dot props dot backend stack. So let's synthesize this first. Const app. It's not Can I just do stack name? I think that should be fine. Get status. Get diff. Get. Let's just see if this synthesizes properly. Cool. Why the hell does CDK synth take like 2 seconds on this thing and it takes like 20 years on mine? What the heck is wrong with my computer? Well, there's probably a lot of things wrong with my computer. It's also running Windows subsystem for Linux, which is, you know, complete trash when it comes to performance. That's probably the main reason. If I were running this on like a MacBook, probably be fine. Great. So let's take a look-see at this thing. Is it fine? Yes. Yes, there it is. It's been updated. So now let's re-enable this transition. Let's see if it works, please. Oh, please work. Please work. This is try number 5. Try number 5. Okay. Okay, this is looking good. npm install, fine. It worked. Har validator. Added 1,000 packages, fine. It's normal npm things. Okay, it's deploying. Okay, it's deploying. Let's go to stacks. Okay, it's been created. Okay, okay. We're getting somewhere. What else is happening? Come on. Come on. Come on. Pause champ. Pause champ. Why does this thing take so long to create? Like, what the fuck is it doing? Okay, here we go. Here we go. Lots of things are being created. Lots of things are being created. Come on. Come on. It's just a default policy. Events. Okay, it's creating the function. Great. Great. Function created. Cool. It's creating, I guess this is the API integration. Okay. API deployment. I don't know what that is. That's created. Cool. It's adding some sort of permission. What the hell? Why is his name so long? What is this? All right. Oh my god, it only took 5 tries. It only took 5 tries, but we did it. Status succeeded. You'll love to see it. It's all green. Okay. Let's take a look-see now. API Gateway, API Lambda, and DynamoDB. Got a couple of functions. This is the function that I want. Hackett, blah, blah, blah. HealthyGamer Workshop backend stack. See, it's got my code. It doesn't have Boto3. That's in a layer somewhere. Okay, it has the table name stuck into it as an environment variable. So this call, oh shit, it's gonna fail. Oh no, oh no, I messed up. Oh god. Call it capital table. God, oh, whatever. Whatever, man. At least it works. What file is this? Whatever. Who cares? Get status. Like, this is minor things. Fix table environment. Doesn't matter. Let's just watch it fail. Oops, not this one. Okay. Okay. So test invoke. Let's see. Test invoke. This should fail because it's gonna say that there's no environment variable or something. Internal server error. That's what I expect. It failed. Unable to import module handler. Okay, well that's a different problem. Attempted relative import with no parent package. Okay, well that's a different problem. That is a different problem than what I expected. Motherfucker. Okay. That is a different problem from what I expected. Oh shit. Backend stack. That is a different problem from what I expected. Why is that happening? Turns out a different problem than what I expected. Handler.listFunc. It's got a handler. It's got a listFunc. So why can't you find it? Why can't you find it? You don't have to do this to me, man. Why can't you find it? Oh! Oh, I completely forgot. I completely forgot. Oh my goodness. Okay. The problem is blogs is a Python module. Blogs is a Python module because it has init.py in it. AWS Lambda doesn't like that. AWS Lambda doesn't like that. AWS Lambda expects handler.py to just exist on its own, and all the other code that you need should be in a separate module. I hate Python. I hate Python path. I hate Python. Everything Python modules related is so fucking stupid. Okay. Make dir lambdas. We'll just call it lambda. Just call it lambdas. Okay. Move init.py into lambdas. Move list handler into lambdas. So now I have to update handler.py. I think it's called lambdas now. List handler. The disrespect, it's not even disrespect, man. It's just like, dude, Python's module system is completely busted. Like who, like legitimately, who thought any of this was good ideas? Like there's so much wrong with it. Yeah, like I just gotta update this handler thing to here. So okay, git status. Git add this. Just like okay, git status again. I'm just renaming a couple of things, like but it's like Python, so it's stupid. So whatever. Commit fix lambda module. I need the full power. Fix lambda modules. AWS Lambda expects Python code to have a handler.py file on its own. Any extra code needs to be a separate module. It's not even disrespect, man. It's just like it is. It just is what it is. Okay. While we're here, might as well talk about DynamoDB. So DynamoDB, you create a table. Like obviously this is the testing table, so it doesn't count. This is my very long name table, HealthyGamer workshop, blah, 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 blah. Let's just make this full screen for now because there's so much stuff. So what does DynamoDB give you? It gives you point in time recovery, which I've disabled. See, what this means is like you could pick an arbitrary point in time, time in the past, and just completely reset your table to that one point. Something that's very not trivial to do inside most relational databases. Okay, encryption by default. You know, encryption at rest by default. You know, some relational databases have something like that, I suppose. But again, drop table, you can't even do that. Like okay, like I could delete it. I mean, I guess I could delete it, but it's like whatever. Like yeah, if you do this, then fine. Time to live. I don't even know what that is. I have like complete monitoring. Like I have access to like you have access to like all the latencies, all the all this like a whole bunch of crap that you just can't really configure otherwise. I have like infinite scalability. DynamoDB, one of the things about DynamoDB is like you can scale up to like ridiculous amounts. For example, like Amazon Prime, like on Prime Day for Amazon, they use DynamoDB, and DynamoDB handles like 20 million requests a second, like ridiculous capacity. Like what the hell? Like how do you even do that? I have global multi-master replication. Like multi-master relational databases is just ridiculous. It's just so complicated to set up. There's like people mess that up all the time. I remember like GitHub had an outage like a year or maybe two ago because their multi-master setup got into a split brain situation where it's just like you're writing to separate databases, but they can't like be synchronized with each other. Yeah, I don't know. Right now, I guess I'm shilling for Amazon pretty hard right now, but you know. Oh, there's one thing. Like I know the people who work on this console, and I told them specifically, hey, this create item UI is kind of bad. You know, it's got all these problems, and the guy was just like, yeah, we know. We're not really gonna fix it. Oh my god. Okay, Python import. I think it's UUID. What is it? UUID.UUID4? Okay. Copy. Creation time. Import time. What is it? Oops. Import time. Time. I believe. Okay, that's fine. Great. So let's just manually create this, and that's fine. It's pretty fast. What's my pipeline doing? My pipeline is still deploying. Oops. Whoops. Like this is really the only time that you use Python is you just like you want a one-liner. It's like, oh, okay, bam, okay, fine. Just use Python for that thing. You're doing like actual systems. Like if you're doing a backend, I would never use Python. If you're using Python for like anything larger than like 100 lines, you're doing something really weird. What language has a good module system in your opinion? Module systems are hard to get right? You either end up with a situation like C++, which has no modules, although they're adding modules in C++ 20. You have something like NPM where they install all your modules locally, which people shit on that all the time for being stupid, but like Rust also does very similar things by just installing and compiling all your dependencies locally into your project directory. You have Python, which doesn't do that at all. Python has something called a Python path, which basically tells Python where to look for modules. And this is really stupid because it's just a list of places and it'll just always match the first item in your list. So that's really dumb. Like if you have like an updated version and it's like but it's like the back of your path, then it just won't find it. So I don't know. I guess those are really the two main ways to do it. I suppose the local option is better, so I guess I prefer NPM and Rust to Python. Are you using WSL? Yes. Yes, I am. Okay. Is this gonna work now? Is this gonna work now? Okay, it's been updated to be decent. Okay, 502 again. It failed again. Malformed Lambda proxy response. Okay. Okay, so this is actually fine. This is actually completely fine. Because the problem, what it's saying is that it doesn't know what my response is supposed to look like. But it actually did execute properly. So if you look here, inside my body, it has my ID and it has my creation time. And these two are exactly what I expect. So 16E2218, 16E22180, creation time 16003027. It's doing exactly what I want. The problem right now is that API Gateway doesn't know what my response request is supposed to look like. And that's a different problem from it not working. It is working now. You can see, like, it's working. It's working, guys. It's actually working. Except API Gateway just doesn't know what to do with it. And we've been going for 3 hours, and my voice is really sore. So I'm going to fix this in session 3.5 next Saturday. Thank you all so much for being here. It's working. Like, it's not working. I mean, it's not working. It's calling my Lambda function. My Lambda function is calling DynamoDB, and it's getting the right thing. But I'm going to fix this in session 3.5 because I've been going for 3 hours, and I need to get breakfast. Even though it's 3 o'clock, I need to get breakfast. So in session 3.5, we'll flesh out this implementation more. And then the week after that, we're going to have session 4, which we're going to talk about front end. We'll describe what a web browser is, and we'll talk about React. It's going to be a very short lecture because there's going to be React is so much code involved. It's going to be like a 15-minute lecture and like 3 hours of code. So there's that. If you guys have any problems, like, I don't want to keep talking. Like, if you have any questions, please just DM me and I'll answer them for you. But I need to get some food. Thank you, and see you guys next week and the week after.